Have you ever realized how sophisticated a nuclear reactor is? Managing an installation of this size requires precise, reliable control. The operators, whose role this is, are assisted by an essential component of the power plant, the instrumentation and control system. Its mission is to ensure the safe production of electricity. And when we say safe, we're talking about the safety of the reactor itself, safety of people, and safety for the environment. The instrumentation and control system is the brain and nervous system of the plant. At the center of the instrumentation and control system are programmable controllers. These comprise hundreds of cabinets full of electronic equipment that monitors the reactor. The programmable controllers receive a constant stream of information about the plant's activity from thousands of sensors. There are all kinds of sensors monitoring temperature, pressure, flow rate, voltage, chemical concentration, and so on. Several times per second, tens of thousands of signals from these sensors are analyzed and processed by the programmable controllers, which can then take corrective action if necessary. Because, in turn, a programmable controller can change how the reactor operates through what are known as actuators. These include devices such as valves, pumps, fans, motors. There are two groups of programmable controllers in a nuclear plant. Operational controllers, which make sure that the reactor is operating correctly, and safety controllers, which take control of the plant if an anomaly is detected. Say, for example, that there's a drop in water pressure in a pipe. The operational instrumentation and control system will order one or more valves to open, returning the pressure to its correct level. But if this does not work, if the pressure does not return to normal and the problem worsens, it is the safety controllers that take control of the reactor. They have only one aim: to prevent an accident. They will order the emergency shutdown of the reactor. To shut down the reactor, they cause the control rod clusters to drop. These clusters are made up of rods that enter the reactor vessel within 2 seconds and stop the reactor. The rods are made from absorbent materials able to stop the chain reaction. The safety controllers then initiate all the operations needed to stabilize and secure the reactor. All these actions, whether linked to operation or safety, are monitored by operator technicians. Nothing escapes their watchful eye. In the control room, which provides the interface between man and machine, they monitor the state of the plant in real time thanks to the data processed, sorted, and analyzed by the instrumentation and control system. Sitting at their consoles, they have all the tools necessary to monitor, analyze, compare, check, and above all, anticipate. This control room is therefore a data center, decision-making center, and control center all rolled into one. The technicians can take control at any moment and have all the equipment needed to control the various systems remotely. The instrumentation and control system of a nuclear plant meets extremely rigorous safety requirements. These requirements form part of plant design, which is based on two principles. The first is diversity. We want to make sure that the different pieces of instrumentation and control equipment do not all fail at the same time due to their similarity. So we use several different methods to measure the same parameter. For instance, to check that the water is the right temperature, we use a temperature sensor, but also a pressure sensor. This is what we mean by diversity, and this applies to all our equipment. The second important principle is redundancy. All sensors, controllers, and actuators together form a complete system known as a safeguard train. Each reactor has at least 2 different safeguard trains, and sometimes 3 or even 4 for an EPR reactor, in case one is unavailable. In addition, these trains are physically separate from each other in isolated buildings to ensure, for example, that a fire affecting one train does not damage the others. They are also electrically separate. Each train has its own power supply. The instrumentation and control system must be adapted to the design of each reactor, the needs of utility companies, and the standards required by the nuclear safety authorities in each country. The instrumentation and control system is extremely elaborate. Its mission is to measure, monitor, check, control, communicate, and protect.